Hello, welcome back. And today we're going to be talking about humidity. And remember that in a mixture of one component which can be condensable, Raoult's law states that the pressure is going to be equal to the vapor pressure. And of course, this is Y times P, so that Y is going to be equal to this vapor pressure over P. And in the system that we're discussing right now, which is water in air, water will be the condensable component, which then this will be the partial pressure of water is going to be equal to the vapor pressure of this water at air at a certain temperature. But this is if the system is in equilibrium, that it does not happen always. So we can define the term of humidity where the relative humidity is going to be equal to the partial pressure, the actual partial pressure over this vapor pressure at the certain temperature times 100. For example, if the relative humidity is 40%, then the partial pressure of water is 40% of the pressure of the vapor pressure of water at the system. We also have concepts like the molal humidity, where this is the partial pressure of water over the partial pressure of dry air, which is the total pressure minus the partial pressure of water. And this is actually the moles of water that we have in the system over the moles of dry air. Instead of molal humidity, we could also have the absolute humidity, which is only the kilograms of water over the kilograms of air. So in order to get to kilograms, we can actually multiply times the molecular weight of water over the molecular weight of air. So this is 18 over 29 molal humidity. So this is the absolute humidity. Also stated as the moisture content. And then we can also have percentage humidity, which is the molal humidity that we have actually over the molal humidity that will be if this is 100%, or we are calculating this molal humidity with the partial pressure when the partial pressure is the vapor pressure. So once again, we can obtain the molal humidity as the partial pressure of water over the partial pressure of air. And the same, but when the partial pressure is the vapor pressure. So this is the percentage of humidity, and of course times 100, so that it can be a percentage. And then we have what we call the psychrometric charts. And the psychrometric chart displays the relationship between the dry bulb, wet bulb, and dew point temperatures and the specific and relative humidity of this system. Usually we're talking about air and water, and given any two properties, the others can be calculated. Dry bulb temperature is the temperature of air that is with water, and we usually determine that with an ordinary temperature thermometer. So the thermometer bulb is dry. But if if it is wet, or if it is covered with a wet sock evaporating into rapid stream of the air sample, then it is the wet bulb temperature. And this wet bulb temperature is the same as the dry bulb temperature when the air sample is saturated with water, which means we have 100% of this relative humidity. And the dew point is the temperature, remember, at which the moist air sample at the same pressure would reach water vapor saturation. And is when water starts to condense, right? At this saturation point, water vapor starts to condense, so we can have some liquid fog. And we can also read from these psychrometric charts the specific enthalpy and the specific volume. The specific enthalpy is going to be very useful in energy balances, and the specific volume of the mixture. And the psychrometric chart looks like this, right? We have here the dry bulb temperature. This is at one atmosphere of pressure. Here we have the moisture content or the absolute humidity. And we have these lines, which are for relative humidity. We also have, so if we say, let's say, we have 30 degrees of dry bulb, right? And we have, let's say, 20% here, 20% of relative humidity. You can see more or less that these lines encounter here. So if we go to the right, we can see 0.005 or something like that kilograms of water per kilogram of dry air. This is the moisture content, right? Or in other, or we can also get, let's say, we can also get to the left the dew point. Here we have the dew point is more or less 4 degrees Celsius. So this line is going to be for the wet bulb and the dew point. For this same example, if we go in a line somewhere like this, we can have the wet bulb temperature. We can also have the enthalpy, but the enthalpy has to be corrected. And these lines that are like here are the correction to the enthalpy or the enthalpy deviation. So once again, in our example, where we have this 30 and we have this guy, which is more or less 20 degrees, we can go towards this direction. So this yields to more or less 15.5 as wet bulb temperature. And then we have, let's say, some 44 kilojoules per kilograms of dry air as enthalpy. But then we need to do a correction factor more or less of minus 0.4, here it states. So it's going to be the 44.5 or 44 that I said, minus 0.4. And also we have these lines. You see these lines that are crossing here for the humid volume or the specific volume. So if I'm right here at 30 degrees and we have here this 20, then I have to go as a line here to state more or less it is between 0.85 and 0.90. So more or less it will be 0.87 or something like that. We have to do this interpolation, right? So this is about humidity and the psychrometric chart, which gives us all this information. So thank you very much.